In this next section, I want to introduce the differences between the two major data processing paradigms in the world of big data, that is batch versus streaming data processing. So in the world of big data, there are essentially two major data processing methodologies or paradigms. There's batch processing and real-time processing, which is sometimes called streaming. With batch processing, data is processed in fixed size chunks called batches. This is where the name batch processing comes from. The jobs are usually non-interactive and they run according to a fixed schedule. There are a wide range of tools available to execute, write, and control these batch jobs. It's a mature ecosystem, and there's strong support with both traditional data processing tools for this kind of batch processing work, as well as with newer big data tools like Hadoop. So even if you're doing batch processing in a traditional database like MySQL or Oracle, you won't have any trouble finding tools to do this. Batch processing is an old, well-known technique. Another nice thing about batch processing is that it's flexible. Jobs can be run easily during the off hours to avoid interfering with other tasks. And batch processing is usually best for time-stamped transactional data. So we're talking about, say, orders in an e-commerce system or other historical time-stamped records from previous points in time, so the previous day or week or month. It's great for historical data processing. Streaming, on the other hand, processes data continuously as it arrives. So you get the data, you process the data, you store the data. All of that's being done in real time or near real time. Typically with streaming or real-time processing, there's no concept of a schedule. So unlike with batch processing, where job scheduling is a big component, with streaming, jobs are running 24/7. There's just one continuous job throughout time that's running all the time, so there's really no need for a schedule. But because of this, you usually require special tools and techniques to manage a streaming workflow, and it's inflexible. You can't schedule jobs around other tasks because the streaming job has to be running all the time. So you need dedicated, full-time, 24/7 CPU, memory, and disk resources to keep the streaming system running. Streaming systems are best for continuous data streams. That would be things like clickstream data from a website, GPS data, GPS coordinates coming in from UAVs or remote vehicles, IoT device data coming in from sensors in microwave ovens or air conditioners or that sort of thing. Basically data that's being continuously collected and that needs to be acted on, processed, and stored right away. So the batch processing paradigm is by far the easier of the two to understand. Batch processing focuses on processing data in groups or batches, usually in an unattended automatic way according to a fixed schedule. So you can see, for instance, here we have two batch jobs, batch number 1 and batch number 2. Batch number 1 is going to be processed on Tuesday at 3 a.m. Batch number 2 is going to be processed on Wednesday, same time, 3 a.m. So these are exactly 24 hours apart, and you'll note that each batch contains 3 data items. So the batches are uniform in size, and they contain different non-overlapping data. That's an important property. Typically, with batch processing, each batch contains unique non-overlapping data, and usually the batches are the same size, although they don't have to be, and they'll be processed according to a fixed schedule. It's very easy to do scheduling in this type of a system and to make adjustments as needed. And on the other hand, there's streaming or real-time processing. This focuses on processing data continuously. So rather than having batches that are run on a schedule, you have a single streaming job or set of jobs that's always running and that processes data as soon as it arrives. So what you actually have is a stream pipeline. And as new items are collected, they get added to this pipeline, which is sort of like a queue, and then items are constantly being pulled from the end of the pipeline to be processed and stored as quickly as possible. So new data is coming into the input end of the pipeline, data is going out of the output end of the pipeline at the same time. There may be discrete data items, but there's a potential for duplication, and there's also the need to ensure that as new items come in, old items are being processed out of the pipeline continuously to keep the size of the pipeline to a minimum. And there's, of course, no fixed schedule because the data can arrive at any time and it needs to be processed as soon as it arrives. So there are a number of different tools to do both batch and stream processing. In the open source world, most of these tools are designed to run as part of a Hadoop cluster. So Hadoop actually does include tools for both interactive data analysis as well as stream and batch processing. So for instance, if you wanted to do batch processing, you could do that with something like Spark, or a scripting tool like Pig could be used to run analysis on data that you've stored in HDFS. You could use a tool like Uzi to schedule batch jobs to run on a schedule. There are a lot of options. MapReduce is the traditional grandfather of batch processing tool sets. So this is the original way you would have done batch processing on Hadoop. There are now many other ways to do it, but MapReduce is the oldest and most mature. And then, of course, there's Spark. Spark can do both batch and stream processing, although I should point out that what Spark actually does when it does stream processing is it just runs very small batches. So it's essentially doing what's called micro batch, which is where you make your batches really small and you run them on a really high frequency schedule to sort of approximate streaming. So that's what Spark can do. There are, of course, real dedicated streaming tools, however, which are what you would use when you have the need for a real-time stream. The most well-known of these is going to be Flink. Apache Flink is the best-known open-source streaming data processing tool. It can run on a Hadoop cluster, but it can also run as an independent system, and it lets you process and analyze incoming data immediately. So it can pull transactional data, logs, IoT data, click streams directly into a real-time event queue, and then Flink will pull that data in as it arrives in real time, process it, and store it. And what's really neat about Flink is that the streaming pipeline can be queried. So the data that's actually in the Flink pipeline, as it's coming in and being sent back out to other applications, you can actually modify the Flink workflow to change the way the data is processed. You can do that in real time, and you can sometimes also query the data that's actually stored in the Flink pipeline before it reaches its output or destination application. Although in most cases, your workflow is going to be take events in, process with a Flink streaming pipeline, dump the events out to traditional storage somewhere else. On Alibaba Cloud, there are a variety of different batch and streaming tools depending on what your application looks like. To manage all of your data warehousing and data import, you'll use DataWorks on the upper left-hand corner of the slide there. DataWorks will let you sort of get an overall picture of what's going on with your scheduled batch processing jobs that are running offline. It will let you build batch processing workflows. It will let you configure ETL jobs. But DataWorks can also manage streaming tools. So you can set up, through DataWorks, streaming tools inside of other parts of the Alibaba Cloud ecosystem. Max Compute, second from the top left. This is our data warehousing tool for long-term data storage and batch processing. MapReduce, this is our managed Hadoop tool. That's in the middle, the top middle portion of the slide there. MapReduce lets you run a Hadoop cluster, which of course means that you can then run your own Flink implementation or Spark streaming on top of Alibaba Cloud MapReduce. That will allow you to do real-time data processing. And then there's real-time compute, which is the second from the right. Real-time compute on the top of the slide, second from the right. That allows you to basically use managed Flink. And actually, Alibaba Cloud has acquired Ververica, which is the company that worked on Flink. So our version of Flink is the enterprise version. So it has all of the enterprise features. So if you use Alibaba Cloud Real-Time Compute, you're actually using a managed version of Ververica's enterprise Flink tool. And then there's special purpose tools for other workflows down at the bottom there. Bottom left, you've got AnalyticDB. That is a MySQL or PostgreSQL database that's tuned for analytical queries. That's actually not for streaming. That's just for ad hoc data analytics. Same thing with Hologres. It makes it possible to do high-speed ad hoc data analytics on the data in your Max Compute data warehouse. And then bottom right, you've got Elasticsearch. This lets you do real-time full-text search over a text corpus, so over text data, which would be things like perhaps log data that you've collected from your Nginx server or Apache logs or somewhere like that. In general, though, for batch data processing and long-term storage in a big data scenario, you're using DataWorks plus Max Compute, or you're using MapReduce if you want to use Hadoop. For streaming, you're using either real-time compute or you're running Spark streaming on MapReduce. Those are the two possible scenarios for batch and streaming on Alibaba Cloud. And that's all for this section. I'll see you in the next section.